Hello everyone, my name is Arshit Naveen. Today let's learn how to use Quartus Prime Analyzer and Chip Planner and even learn how to modify the default FPGA placement. First of all, let's open the Quartus software. So I have opened the Quartus software. As usual, we will follow the initial steps to open a new project by assigning the working directory name and selecting a proper device. So over here, I've selected the working directory and given a name for the project. Then let's click next. This is the crucial step. Let's select a proper device. It is 5CSMA3F5C16. This is the one, 5CSCMA5F31C6. Let's click next and finish. Now let's import the files. So we need to import all this. So these all files are given for us in order to do this project, because the main objective of this assignment is to learn and modify the timing analyzer and the physical design in chip planner. So this module is the IR receiver and emitter. So let me open all this, and we also need to add the stc file. So you guys may not be having all these folders or all these files, so make sure you create your own. Apply. Once it's done, just and remember you have to select this as a top level entity, otherwise you would get an error. Selecting the dot as a select top level entity. Now I've compiled it. Once compilation is done, you can check the fitter report. Total registers 284 and 183 ALM. Now let's go for the timing analyzer. Go to tools, press timing analyzer. Once this window pops up, make sure you need to compile the create timing netlist, read the stc file and update the timing netlist. Then scroll down. Over here you will find the report fmax frequency, and then if you scroll down you will find the report timing. In this we will be reporting the 5 paths. So over here the 5 paths have been reported. You can see this slack are positive. This is a from and this is a to node. This is the data delay. Now this is the timing analyzer window. Now let's try to modify the physical layout in the chip planner. So to open that, make sure you choose right click, go to locate in chip planner. So you have to change this to the zoom in button, and this is the region where there is a critical path of 5 longest. Now since the objective is to modify the physical layout in chip planner, let's take any 2 blocks from this, and let's assign one block to the left corner and other to the top left corner. So in order to move this, you have to change the editing mode to the assign mode, and then you have to click this arrow mark. Once it's done, make sure whenever you click this block, you have to get a cursor button. Once it's done, you can pull to the left of it and you can assign it to the block in this way. See, you can able to see the assign block. So I'm assigning it to the left corner of this. So I'm assigning to this block. Once you have done assigning it, you will able to see the new node name and its new location. Similarly, I'll be doing with the another block, trying to place it on the top left. So I have assigned the one block to the top left corner over here. In this window you can able to see the new location of that. Now let's close this window, again recompile it, then we would be getting a new timing analyzer report where the slack will be different. So you all can see that slack has been changed when we move the two blocks. Let's open and see how the chip planner will look like. How a chip planner will look like when I shift two blocks, one to the top and one to the bottom. Now let's program this device into the FPGA. Now let's program this .v into the FPGA. So we all know the traditional way of programming the FPGA is to click the program device. Now we are going to program it not by clicking the program device, but we are going to use a different called batch file. This is my working directory in our source IR which was provided for us. In that I have to select the demo batch. In this demo batch they had provided as the de1 soc underscore ir dot bat file. So in the demo batch folder we have to include the SOS file which we use to program the FPGA. If we include the SOS file in the demo batch file, so next step is just click and run. So you can able to see that ended successfully performed operations, ended program operation, Quartus prime program was successful, goodbye. So this is how you will program the using batch file. Let me give another example how the batch file can be used by using this batch file in order to program the FPGA of the multiplier. Second example of using a batch file. So I have included the batch file in the working directory of the multiplier 2x2 where I will be displaying the value on the 7-segment display. So this is the demo batch, and over here in the demo batch I have included the 7-segment display.sof file, and this is the batch file. So you have to make sure that both the batch file and the .sos file does match. Once it's matching, and you have to change in the crucial part as well, you have to make sure go and edit. Whenever you're trying to use the batch for some other projects, make sure you have to change the name over here as well, the .sos. So in the previous assignment we used a different SOS file. Now since I am using to program the FPGA for the multiplier, I have to change the .sos file. Once you have changed that, make sure the naming is same for SOF and the batch file. Once just done, just make sure you run. See, we got again the goodbye message. So here you can clearly see that the FPGA has been programmed using the batch file. This is a second example of using a batch file. This is how you program using a batch file. Thank you.